All right, now let's tackle, in the last video we did the first part of part A. Now let's do the second part of part A. So the second part of part A, they say calculate the number of moles of ethene that would be produced if the dehydration reaction went to completion. Well, this is the dehydration reaction right over here, and they're telling us that we start with 0.200 grams of ethanol. So if we start with 0.200 grams of ethanol, and if we figure out how many moles of ethanol that is, well, for every mole of ethanol, if we have the reaction go to, if the dehydration reaction goes to completion, for every mole of ethanol that we start with, we're going to have a mole of ethene and a mole of water. So if we can just figure out how many moles of ethanol this is, then we'll say, okay, if this were to completely react, we would have that many moles of ethene. So let's figure this out. So if we say, so we have ethanol. So for ethanol, we are starting with 0.200 grams, and we want to convert this to moles. So we want to multiply this times, we want grams in the denominator to cancel out with this grams, and moles in the numerator. So 1 mole of ethanol has a mass of how many grams? Well, they tell us that earlier on in the problem. They say ethanol, molar mass 46.1 grams per mole. So ethanol, molar mass of 46.1 grams per mole. Or another way of thinking about it, 1 mole would have a mass of 46.1 grams. And so if we do this, we are going to get 0.200 over 46.1, and then grams cancel with grams, and that's going to be how many moles we have. And this is going to be equal to, we have 3 significant digits that we're going to be dealing with, 3 significant digits divided by 3 significant digits. So this is going to be, all right, so let me clear this. So 0.2, I could write 00, but it's going to, for the calculator's purposes, it's the same thing. Divided by 46.1 is equal to 0.0043. I want 3 significant figures here. So 43, I'm going to round up, 0.00434. So 0.00434 moles. So what we've seen so far, if the ethanol were, the reaction, if we have this many moles of ethanol, well, if they completely react, well, then we should end up with that many moles of ethene. And so if we could say dehydration, let me write it this way. If dehydration reaction goes to completion, every mole of ethanol would be converted to a mole of ethene and a mole of water. I shouldn't write the shorthand there. A mole, if I'm writing it out, mole of and a mole of water. So 0.00434 mole of ethanol would yield that same number of moles, 0.00434 moles of ethene. So if the reaction went to completion, that's how many moles you would produce. What we actually measure is a smaller number than that. So the reaction didn't go fully to completion. So now let's tackle part B. And they ask us, calculate the percent yield of ethene in the experiment. Well, that's the percent yield is going to be how much we got divided by how much we would ideally have gotten if the reaction went fully to completion. So yield is going to be equal to how much we actually got, which we figured out in part 1. So 0.00264 moles over what we actually got. Or sorry, what we actually got over what we would have ideally gotten if the reaction went to completion. So divided by 0.00434 moles. And this is going to be equal to, so 0.00264 divided by 0.0434 is equal to, and let's see, I have 3 significant digits here. So 60, I could say 0.608, or I could say 60.8% yield. So I could write this as, actually I'm rounding, so I could say a 60.8% yield. And there you go.